day 2. This should go pretty quickly. We really only have one problem to get through. And I'm not showing you anything different. I'm still doing chain rule. I'm just kind of extending it a little bit further. I guess so that we could split this into 2 days. You could have 2 full homeworks on it because you need it. You need this chain rule practice big time. So here we go. I'm going to, it says, find the slope of the line tangent. Oh, look at that. Ding, ding, ding. Something should be going off in your head. Slope of the tangent line, you need to do a derivative. Now, here's your function. It's sine of x to the 5th power. Some of you are absolutely fine with writing it like that. Remember, don't you dare write it like that. That is so wrong on so many levels. Or if you know that you're going to have to do the power rule and you want to think of this as y equals the quantity of sine x to the 5th power, that might be really helpful for some of you to do just a quick rewrite, kind of like if we do radicals to the 1/2 power. Just put your quantity in here and it's to the 5th power. So this is your, I'm going to highlight it, this is your messy. Here I go with my derivative. Y prime equals, I'm going to power rule it. Messy stays the same. Lower it. Times the derivative of the messy. This is the derivative of this function anywhere. This is the slope of the tangent line anywhere, at any x. We want to find the slope of the tangent line when x is pi over 3. Plug in pi over 3 and label that you're plugging in pi over 3. Okay, trig, sine of pi over 3. Kind of rusty, haven't done this in a while. Sine of pi over 3. So here's pi over 3. Sine is going to be radical 3 over 2. And cosine is going to be 1/2. Now if I raise this to the 4th power, I've got that times that is 3. Times another 3 is 9. 9 over 2, 4, 8, 16 times 1/2. So it looks like I've got 45 over 32. All right. B, show that the slope of every line, oh, this one's completely different. Show that the slope of every line tangent, oh, keywords here. You see what it's telling me to do. At this point, you might not know exactly what to do, like, how am I supposed to show that? Well, I don't know yet. But you know that it involves a derivative, so do a derivative, then reread the problem. Okay, this is the way it looks. Hopefully you recognize this is messy raised to the 3rd power. Hopefully you also recognize that you have a quotient. Now, so you have a quotient. You could totally do quotient rule. Sing your song, start in the denominator. You could totally do quotient rule. But another way to think of this is maybe move that to the numerator and make your exponent negative. Doesn't matter to me. I think most of you would prefer doing it this way. Let's recognize this is messy, and you can go ahead and start to power rule it. Careful when you lower it by 1. And then multiply it times the derivative of the blue, derivative of the messy. So the derivative of a constant is 0. The derivative of negative 2x is negative 2. I got positive 6 over this quantity to the 4th. Okay. What do the directions say? Show that the slope of every tangent line, show that the derivative is positive. Show that the derivative is positive. Well, think about this. When I multiply the negative 3 by the negative 2, I've got a positive 6, okay? So that number's 6. It's always going to be positive. What about the denominator? Doesn't matter what you plug in for x. When you do this math and you raise whatever you get to the 4th power, aren't you going to get a positive? Always? Any exceptions? Thanks. I'm glad somebody thought of that. What about when x is 1/2? When x is 1/2, you get 1 minus 1 in your denominator. Oh no. So is 6 over 0 positive? No. But you know what? Come back up to the original. Come back up to the original. Where is it? Here we go. Is 1/2 even in your domain? Like, should we even be talking about 1/2? No. So this function, it was all fine and good. It has its own domain. I never asked you what the domain was. We don't talk about that very often. But I do know that this function has a domain that excludes 1/2. Because we don't want my original to blow up. Let's not let x be a half. Don't go there. Don't let x be a half. So carry that domain forward. Carry that domain to your derivative. Knowing that x can't be a half, yeah, it's always positive. So this is never negative because it's a positive 6 over something that's being raised to the 4th power. And we already are excluding x equals 1/2 because 1/2 is not in the original domain. So knowing that x can't be 1/2, it could be anything else, doesn't matter what it is, when you plug it in, the result of this fraction will always be positive. Woohoo!